Hello guys! I've decided to make a video about new features of Octane Render for Blender version 3, and I'm going to start from Visible Environment. So from version 3 we have a new node, Octane Visible Environment. This node can be connected to a render target if you need to override reflection or refraction from your normal Octane environment, and also it can be used as a backplate image. So I have a very simple setup. The cube with a specular material and the sphere has a glossy material. And as you can see, so far I have very simple daylight environment. In order to make this one works, we need to add a texture into our environment settings. Add an image. Name it. Okay. Don't forget to add the same texture into your texture slot. And now scroll down. Here you can find three different options: backplate, reflections and refractions. Let's start from the first one. Okay, pretty simple. The next one, reflections. This one works for both specular and glossy materials. And the last one, refractions. Refractions works only for specular materials. Another new feature, environment medium. From version 3, creating a fog became much easier. We need to add a medium node into our Octane environment settings, and when we do so, this medium is applied to a virtual sphere around our camera, and the size of this sphere is determined by medium radius parameter. So let's try to do this. You can use any of these nodes, and I'm going to use this one. Connect them, name it, add the texture to a medium slot, and let's take a look. Change scale parameter, and we have a fog. Also, we can add some color to our fog. Okay, let's leave it this way. I was asked on the forum if there is a possibility to make different level of fogginess for different objects in regard of their distance from a camera. So I've prepared a scheme which I hope will help you to understand. Imagine that you have a scene with different objects in different distance from a camera, and this circle, it represents the size of your virtual sphere. So if the size of this sphere is smaller than the distance to closest to a camera object, all your objects will have the same level of fogginess, no matter how you change your Octane medium settings. But if you make it big enough to cover all your scene, you can make different level of fogginess for different objects. So let's take a look at another example. I have a plane here, and the size of this plane is 25 by 25 meters. So the distance from this point to this point is more than 35 meters. Okay. As you can see, so far the size of my virtual sphere is not big enough to cover all my scene. So these two cubes, they look completely the same. But if I change this parameter to, for example, 45, I mean bigger than this distance, and change a few settings here, as you can see, now this cube, it looks more foggy than this one. Another new feature, support of outer smooth angle parameter. This one can be useful if you have enabled smooth in your Octane material settings and you need to exclude some bigger angles from smoothing. If so, go to Object Data and enable this checkbox. Now you need to change this angle parameter. From now on, Octane engine uses its own normals, which are generated based on this angle. Another new feature is texture baking. Baking is a process of extracting lighting information from a mesh by using its UV map to generate a texture that later can be mapped back to the mesh. Some main advantages of baking are speeding up render time and reducing polygon count. In order to use baking in Octane, you need to change your camera type to a baking camera. Go to your camera settings, Octane camera rollout, and here you can find your baking camera settings box. Baking camera has only one position and direction per sample, and the way how they calculate it depends on the input UV geometry and geometry itself it being baked. There are two conditions in using texture baking. First of all, your mesh should have at least one UV set, and secondly, there shouldn't be any other geometry mapped to the same UV region. So, I have a cube here, and I've already unwrapped it, and also I applied a diffuse material with a texture connected to a diffuse slot. So let's take a look. Okay, my texture is baked. Now I can save this image and apply it later to my mesh. Another new feature is support of OpenVDB. So far we have support for small cache type only, but this limitation has nothing to do with the plugin, it's about Blender itself. And as soon as Blender's developers add full OpenVDB support to Blender, Octane will catch up and we will have it too. So now we are talking about smoke simulation. And smoke simulation involves at least two objects, a flow object and a domain object. This sphere is going to be my flow object, so I need a domain. I can add it in two different ways. First of all, I can add a cube to my scene. Move it a little bit. Scale it if I want. Go to Physics Properties, Smoke, and choose Domain as Smoke type. Now select the flow object, Smoke again, but this time Flow as a smoke type. Or I can do it differently. I just don't need this and this. Select the flow object, go to Object, Quick Effects, Quick Smoke. Now I need to change file format in Smoke Cache Rollout from Point Cache to OpenVDB. If this settings is inactive for you, it means that you didn't save your project. Now I just want to change my settings a little bit in order to keep my simulation faster, but at the same time still interesting for you. Just give me a second. Something. Okay, let's see. Okay, I like it. And now I'm ready to bake my simulation. And it's going to take some time. Okay, my simulation is baked. You can affect your smoke simulation in two different ways. First of all, you can change Octane volume medium settings parameters. And secondly, you can go to Object Data, scroll down, and here you can find Volume Properties settings box. Okay, let's add some color. And let's see. Okay, we have a smoke. Changing a few settings. Okay. Also, I can change the color. And I can add even more color. I just need to connect Octane volume ramp texture to my absorption ramp. I just don't need this anymore. And here something in between, let it be red. And the last one, let it be blue. Okay. Max grid value parameter. This one is really important, and you can read about this parameter in Octane standalone manual. Now I'm just going to show you how changing this parameter can affect your smoke simulation. Okay, let's leave it this way. Interpolation type. 1 stands for constant, 2 for linear, and 3 for cubic. And let's change something here, for example, absorption scale. The next feature is going to be really useful for those of you who uses hair system a lot. Minimal curvature parameter was added to Octane hair system. So let's take a look on this example. The problem is that Blender manual doesn't explain this part clearly, but this parameter steps, it doesn't represent the real number of control points. It actually represents the power of 2 as a real number of control points. It means that if you have 6 here, for example, you have not 6 control points per hair, but 2 in power of 6, 64 control points per hair. So it could easily overload all the memory of your computer if you have too many hairs with this amount of steps. For example, you have 100,000 hairs and let's say 10 children per hair and 64 control points per hair. So now you have more than 64 million vertices only for hair system, and it's unlikely that your machine will be able to handle this amount of geometry. So about this new parameter, it actually checks an angle between the previous and the next segments, and if this angle is smaller than the given one, plugin skips next vertex from loading into Octane engine and loads one straight segment instead.